Hello guys, welcome back to online class for excellence. In today's class, I'm going to discuss about force that is included in class 10 syllabus, and mainly what are the points or what are the parts that you guys need to know before we go into the chapter are like what is translation and rotational motion, what is the turning effect, you can say the term like moment, couple, these are all terms that is included in this turning effect part. And number 3 is equilibrium, it is translation and rotational. And number 4 there is Cg, that is center of gravity, you can say it as Cg as well. And number 5 is circular motion, that includes centripetal as well as centrifugal force. So basically what is a force? Force, as you know from like Newton's first law of motion, force is an external object that is applied to an object, external subject that is applied to an object in order to change its state of rest or state of motion. So when a force is applied over here, so it produces a motion. So we will discuss in this chapter like what are the types of motion and where the force is being acted upon and why it is acting and all. And we'll discuss the sums as well of this chapter. So coming to the first point is like translational motion. So what is translational motion? So basically it is a motion where an object is like moves on a as a like whole on every point, and it covers the same distance in a given interval of time. So if the car is moving and it is given 5 minutes, so it will cover equal distance in 5 minutes of time, like 1 minute, 1 minute, 1 minute, 1 minute, 1 minute, so 1, 2, 3, 4, 5. So in 5 minutes it will cover equal distances. That's called translation motion. And rotational motion, like it will move based upon a fixed axis. Suppose this is an axis, so the ball is moving over here. You are like rotating a ball. So tied to a rope, so this is a axis, so it's happening like rotational motion. Now number 2, it's like turning effect of a force. What is the effect of turning effects? Number 1 is the moment, number 2 is the couple. So what is the moment? The turning effect of a force on an object about a given axis or a given particular fixed point is known as moment of a force. This is suppose this is a door, alright? You all experience this every day. So this is a door now, this is a door knob. Now when I'm opening it like this, so it is the door is coming towards here based on this particular axis. So it is performing a rotational motion towards this side, and it is happening on this two portion, the hinge, you can say, hinge on the door. So this is particularly an example of moment of a force. It happens clockwise and anti-clockwise. Like if you say clockwise, anti-clockwise. So the direction of the force that the direction of the force determines the direction of the moment as well. And like if you say like what is a couple is nothing but it's basically some when two equal and opposite parallel force acting on a rigid object along different lines constitute a couple. So basically suppose over here one stone is being kept and this at this point a stone is being kept. So over here a force is being applied, over here equal force is being applied, it is being rotated around a fixed point, particular fixed point. So basically over here two like turning force are happening, and it's happening in this case like a particular fixed point. So in this case I will say that it is performing a couple. So opposite and parallel force. Suppose I'm forcing it over here. So opposite, this is like downward, this is like upwards. It can be like opposite or it can be downwards as well, depending upon the direction. So it will be minus at that time. And this is basically a couple. It can happen clockwise and anti-clockwise as well. And now if you come basically what is the equilibrium of a force? So equilibrium of a force is translational and rotational. Translational means the object is said to be in translational equilibrium if it remains at rest or continues to be at rest at a given direction with constant velocity. Like it is moving with uniform velocity, otherwise it is at rest. So it is translational equilibrium. Rotational equilibrium, it is said to be in rotational equilibrium if it maintains a state of uniform rotational motion or zero rotational motions, like it is moving around a particular axis in a particular constant speed, otherwise it is at rest. So this is known as rotational motion. It is continuing at a particular velocity. Now what is center of gravity? So center of gravity is nothing else but it is particularly a point, like what we think, what we imagine. Like center of gravity of an object is a point where the whole weight of the given object acts upon. Suppose this is a rock, we'll consider it like this is the point, the midpoint of this circular rock, and over here the whole weight of the stone is being acted upon on this point. So this is the Cg of the center of gravity. So basically we considered it like a particular point and where the whole weight of the body is being concentrated. So you guys know W equal to mg. So if you consider this m1, a small mass, this is considered as m2, m3 and all. So g is same for each case. So over here this will be equal to like m1 g plus m2 g and so on. And I will tell you guys like some examples of like some very familiar objects, the CGs. So thin uniform rod, the CG, the center of gravity will be in the center of the rod. Uniform circular ring will be at the center of the ring. Uniform circular disc will be at the center of the ring as well. A plain lamina, it will be a like kind of rectangle and all. It will be the like the intersection point of the diagonals. Rectangular as well, parallelogram as well as rhombus as well. In a triangular piece of lamina, it will be the centroid, the median, the intersection of the three medians. Uniform hexagon will be the point of the diagonals as well. Cubical will be again the intersection of diagonals. Parallel pivot will be again the intersection of diagonals. Spherical will be again the center of the shell. Solid sphere will be the center of the sphere. Solid cylinder will be the middle point of the axis, cylinder, and as well as in solid cone as well. In case of solid cone or pyramid, it will be basically on the axis of the cone or the pyramid at a height of h by 4. H by 4, like if the height is like 4, the center of gravity will be at 1 meter from below or up. So this is a uniform cone or pyramid, and uniform hollow cone. In case of hollow cone, this is solid cone. In case of hollow cone, it will be the formula will be just like h by 3. Alright, so these are the, you can note it down, you can pause the video or like write down the main points which I have told you. And now basically one thing more, like what is circular motion. Circular motion is nothing but when an object is moving in a circular pattern as well. So centripetal force and centrifugal force, this is basically again we will come into the solar system part. Like it's a perfect example for this. The earth is moving around the sun. So the sun is attracting the earth in a particular way, and again as equal and opposite reaction, each force has an equal and opposite reaction according to Newton's third law. The opposite force that is being acted upon by the earth, like one is like the sun is pulling the earth, so obviously the earth will also pull the sun. So this is basically nothing but the centripetal and the centrifugal force. Centripetal force is basically the force that acts upon uniformly, like an object that is moving in a uniform path, circular path. It always acts upon like the radius directed towards the central of the circle. So this is the radius, and it will, if this is earth, this is the sun, so this is earth, so it always occurs along the radius and it directed upon the center of the main axis. So this is centripetal force. The opposite force that is being acted upon over here, it is the centrifugal force. Centrifugal force is the imaginary force due to incorporated effects of inertia. Inertia, again the main thing, the Newton's law, the opposite force that is being acted upon. And the one more thing that is over here, that is I have left in case of this, like principle of moments that you guys need for your mainly sums and all. So principle of moments is nothing but, if suppose this is you consider this as a rod, this is a pivot point, this is a weight W1, W2, W3. So it is being like, if this comes down, it will go up. So obviously this is much more heavier than these two weights as W2 and W3. So this is W2, W3, W1. So the principle of moments is like, basically in a case of equilibrium, the sum of all anti-clockwise movements will be equal to the clockwise moments as well. So the clockwise and anti-clockwise, suppose this is the clockwise at W1 G will be equal to W2 G plus W3G. Alright, you guys get it? Because it is in equilibrium. So when principle of moment it comes when the body is in equilibrium. So equilibrium means जो भी होगा left side में उसका जो moment होगा that will be equal to the right side or vice versa. So this is the basically principle of moment. So I will come back with these problems of this chapter, and basically guys mainly wrote it down, like the moment is important for you guys for class 10 for sums and numericals as well, and rest of the part is basically the sums that are kept over here, and I will come back with the sums. If you guys need to note down something, you can note it down. If you have any doubts, do write in the comments. I will come back with the sums part. So guys, these are some of like 5 numericals from this chapter, force, and you can write it down. You can pause the video and write down the sums. So first, before going into the main part, I will tell you one more thing. Like in the last theory part, I have told you center of gravity of various kinds of objects. For in case of CG of an uniform rod, it is always at the midpoint of the rod. Whether it is a seesaw, whether it is like a rod, whether it is a like bar, uniform bar, always at the middle of the rod. So number 1. A boy of mass 30 kg sitting at a distance of 2 meters from the midpoint of the rod. Where should a boy of like mass 40 kg should sit in order to balance? So over here we will just draw the diagram like this. So for this, suppose this is distance of 2 meters from the mid of the rod. Suppose this is the rod, this is the midpoint, and over here there is like one 30 kg boy sitting over here, like this is 30 kg, you can say. So where will this 40 kg over here will stand in order to make this in equilibrium? So obviously what the main thing will be, so over here and over here, the two forces are acting over here, and this is the midpoint, this is the fixed point on which the balance is being done. So over here it's nothing but, if we will take it as x, this point x from the midpoint. So let the boy will sit at a distance of x meter from the midpoint, 40 kg wala. So like for the main moment we will see like in such conditions the force will be equal and opposite. So these two are equal, this will balance, neutralize. So force into like displacement, you can say like force into displacement will be equal to x into 40. From this equation we will find x from here. A stone of mass m is rotated in a circular path by a string at uniform speed. So this is like your stone is being revolving around with the help of my hand and the string, and it is doing like this. So number 1, the stone, the speed is variable or constant. Obviously this is constant. Stone uniform acceleration, obviously it is undergoing a uniform acceleration obviously, and it is directed along the radius towards the center of the circular path. As I've told you again and again, in case of solar system as well, again and again I'm telling you, if this is the stone and this is the axis, or like I'm revolving it around this axis, these two forces will automatically react. One is the like this is the centripetal, and the centrifugal force will act over here, and mainly the acceleration is uniform and is always directed towards the center of the circular path. And number like third part, force on hand and direction. On hand, like my hand, so basically it's a centrifugal force acts on the hand, centrifugal force, and it's radially in outward direction towards outward. So inward is centripetal, outward is centrifugal. So now number 3, one end of a string is tied to a stone of mass 0.2 kg and the other end to a peg in horizontal board. What is the tension of the string if the stone moves horizontal path with a speed of 1 meter per second? So over here again the same thing, the tension is the string is the required centripetal force. Like when one end of the string is tied to a stone and the other is in the horizontal board, what is the tension of the string if the stone moves horizontal path like with speed of 1 meter per second. So here there is a constant speed, so tension is in the string is nothing but the centripetal force. So here F will be equal to mv square by r. So like this is mv square. So by r. Okay. So now over here we can put the values of m, we can put the values of v, and we can put the values of r. R is nothing but the radius, and over here r is this 0.6. Okay. So from here in Newton it will come, the answer will come 0.33 Newton. Okay. mv square by r. So that is this like the tension. Number 4, uniform meter scale can be balanced at 70 marks when a mass of 0.05 kg is hung from 94 centimeter mark. Find the mass of the meter scale, and like you can draw the diagram as well. So here the diagram is nothing else but it will come like this. This will be the center, and it is like it is over here can be balanced at 70th mark. So this is the balance is happening over here. So this is the balance. So this is 70 meters. Over here the weight is like 0.05 kg, and from over here I am taking a mass of this kilogram force in order to balance the system, in order to place it in equilibrium. So over here always remember this two part. Clockwise movement will be always equal to anti-clockwise movement, otherwise equilibrium won't happen, guys. So for here clockwise movement will be equal to anti-clockwise movement. So over here the clockwise, for the clockwise movement it will be the mass that we are taking and 70 minus 50. Why we are doing 70 minus 50? This is 70. Alright, so if this is 70, so we can say over here this is suppose 50. So this part is 20, and it will be equal to 0.05 this kg force minus 94 minus 70. Why 94 minus 70? Because over here we can say this part was 94 centimeter, this is 70. So this we are calculating over this midpoint only, guys. So over here m will come as 0.06 kg. Number 5, we can like I've drawn a diagram over here. It is a pivot point, and this is one weight is over here, 1 kg force, 2 kg force, 1.5, and again a force is acting. This is a hinge that is being struck like fixed, and from here string is over here, and obviously the string, the force of in the string will be always upward because it is being held up, and these are the weights. So find the tension present in the string in Newton, in the string only. So over here again the same thing, equilibrium, from maintaining equilibrium at the main point, at the midpoint, the total moment will be equal. So over here I will just write the equation for you guys. You can calculate it later. So minus 1.0 kg force into 0.5 meter, 2 kg force into 1 meter, minus 1.5 kg force into 1.5 meter, plus the tension will be equal to 0. All the force will come to, you can like take it over here as well, the minus, because over here all things are minus because of the direction of like the anti-clockwise and clockwise, and over here we the tension over here, this is opposite to these three force. These are acting downwards and this is acting upwards, so I have written it as plus, and all this force will be equal to nothing else but 0, because we have to make it like equilibrium. So over here this will come as nothing but T will come. I will write the answer, guys. You can do the calculation by 23.7 Newton. So there are various kinds of other sums as well. So if you want, I can write other sums as well in the comment section. Do write your doubt, do clear your doubt, do ask me any queries if you have in the comment section. Till then, I will again come back with a new chapter of chemistry. So you can write it down. This is basically the 4th chapter. So this CG and all will come in your class 11, 12 as well when you take physics. So guys, this is all from this video. Do enjoy studying, keep on studying, and be safe. Thank you.